everyone. So this is going to be a really low tech video. I just felt like trying to show my phone as the calculator and switching back and forth was going to be too complicated. So I apologize. Hopefully this works out and is sufficient. So I wanted to take a few minutes to go over the second sample problem from class today in a little bit more detail and to show you the buttons on the calculator and give you a process for that. So in this problem, we had two negative 6.5 Coulomb charges, and they were 66 centimeters apart. And we wanted to know the direction and the magnitude of the force between them. So let's start with the direction. If we represent our two charges as these circles, we know that they're both negative, and negative charges repel. And so if we wanted to draw in force arrows, we would draw them in opposite directions. Right? Those two charges are being repelled away from one another. And then the magnitude, we're going to use our Coulomb's law equation. So we're looking for F, which is the force. K is our constant. We know it's 9 times 10 to the 9 Newton meter squared over Coulomb squared. In this case, our two charges are the same. You'll remember from class that in order for this equation to work, we just use the absolute value or the positive version of the charges. We don't really mess around with negative numbers in here, which is terrific. So 6.5 coulombs, 6.5 coulombs. And then our distance is 66 centimeters. In order for this equation to work, we need our distance units to be the same. So we're going to take a second to convert this into meters. So we'll be wondering what it is in meters. We went over this briefly in class, but since it's been a while, I'll go through it quick. So we'll start with what we know. 66 centimeters, that's a little ugly, sorry, over 1. And then we're going to make this fraction what we call like the unit converter. Right, this fraction is equal to 1, right? When we multiply anything by 1, we end up with the same thing. So in this case, we'll end up with the same distance, just with different units. So we put the units that we want to get rid of on the bottom of our unit converter fraction so that they'll go away, right? We cross out top and bottom. And we'll put the units that we want on the top. And then we need something that makes the top and the bottom of this fraction equal to the same thing. And we know that 1 meter is the same distance as 100 centimeters. And you could look that up if you didn't know it off the top of your head. Then we're just going to do the math. So 66 divided by 100 equals 0.66 meters, right, the unit we have left. And that's what we'll be using in our equation. And if you need to use a calculator to do this math, you could certainly use a calculator. Okay, so now we're at the point of plugging into our equation. And because I have more room here, I'm going to do it in a slightly different way so you can see how the units work out. So I'm going to draw a really big fraction bar. And my constant K has units on the top and the bottom. And for this example, I'm going to show you with them on the top and the bottom of this big fraction bar. So K, I'm plugging in, is 9 times 10 to the 9 Newton meter squared over Coulomb squared. You can see how those units are on the top and the bottom, just like they are over here. All right, and then I'm going to plug in my Q's, my charges. Okay, so this is my K. Q1 is 6.5 coulombs, Q2, 6.5 coulombs, and then my distance, 0.66 meters, and that whole thing is squared. So at this point, I'm going to pause and look at my units. And I know that if I have units on the top and on the bottom, I can cancel them out. So here I have 2 coulombs, and here I have 2 coulombs. So those will all go away. And then here you have 2 meters, right, meters squared. And here I also have meters squared. I just want to be really careful when I cross out, right? You can get rid of all of this, but I'm just going to cross out this meter here because now it's gone, right? I know it's gone, but I don't want to forget that I need to square this 0.66. So I'm going to leave the 2 there just as a reminder to myself. Okay, so I'm left with newtons, right? That's the only unit that's left. So that will be the unit in my answer. And that's awesome because I know that force should be in newtons, so I have what I'm looking for. Okay, the last step is to plug things into my calculator. You guys asked that I would use my phone calculator, which I am happy to do. If you're using a scientific calculator, the buttons are the same. They'll just be in a different spot, but you can use the same functions that I'm going to use here. So the 2 most important buttons for this are going to be this double E button. That double E means times 10 to the, all packed into 1. So here when I see times 10 to the, I'll just use that E button for all of it. And I'll write that down for you here as well. Right, the double E button equals times 10 to the. Okay. So my workflow is going to look like this. 9 times 10 to the 9 times 6.5 times 6.5, right? Times and times. And then divided by 0.66. And then I'll use, there's this button here that's the squared button. I'll use that. And then I'll hit the equals button. And I'm going to try and plug this in as all one thing. All right, so here we go. 9 times 10 to the 9. And I'm going to hit equals there just to show you because this is a new button that we haven't used before. We know that this times 10 to the 9 means that there's 9 zeros after, and that's perfect, right? That looks good. Okay, now I'm going to keep going. Times 6.5 times 6.5. Okay, and then divided by 0.66. And it's important to not hit equals here because we just want to square the 0.66. Okay, and now got that squared, equals, and this is my answer. So this is a really big number, and you could write it just as it is. I'm going to write it in scientific notation because we practiced that. And so my decimal is here, and I'm going to move it over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 8.7, and it'll be 7.3 because I'm rounding, times 10 to the 11. And again, we talked about how 3 significant digits or 2 places after the decimal was sufficient. You don't need to write down all of these numbers. And that's my answer, 8.73 times 10 to the 11 newtons.